Hello,
Ooh,
officially everybody. Welcome to our webinar today. We're going to be introducing you to the new Cellular plus Wi-Fi note cards, the new Notecard Wi-Fi, and the new Notecard LoRa. While we have a super packed agenda, I'm also pleased to welcome RAKwireless to our presentation as well. We've been working closely with RAK for some time now and are pleased to show off some of the results of our collaborations today. More on this a little bit later. Before we really get started, of course, if you have any questions, I mentioned this already, but any questions today, enter them as soon as they pop into your mind in either the chat window or the QA windows that are provided. We'll do our best to answer questions as they come in, but then hopefully we'll have time at the end to answer some of them publicly. Speaking of questions, we always get the question, is this being recorded? Will it be made available? The answer is always yes. It is being recorded. It will be available on the YouTube channel for Blues at this URL. When you're there, of course, I recommend subscribing to the channel so you're the first to see any and all of our new video content. Also, make sure you're aware of our new technical blog. So available at blues.dev/blog, you'll find all sorts of relevant content about the IoT, embedded development, and some tangentially related technologies. It's really great. We've got it seeded with a lot of good content. I recommend taking a look, bookmarking it when we're done with the webinar. And with that, let's kind of jump in and kick things off. So I'll start introductions. I'm your first speaker today. My name is Rob Lauer. I'm Director of Developer Relations here at Blues. And I want to start with a simple question. Why? Why are we releasing these new note cards? Or now that I say this out loud, maybe the question is more, how did we get here? And I can answer this in a phrase, and that is wireless harmonization. You'll hear a lot about wireless harmonization from us going forward. This is the idea that product builders should be able to choose the right radio access technology, or RAT, to build connected solutions without making those upfront commitments, without painting themselves into a corner. Why is this important? Well, for most modern IoT applications, choosing between cellular, Wi-Fi, LoRa, BLE, satellite, whatever it might be, it's usually a decision you're forced to make up front, partly because of incompatibilities between radios, maybe provisioning issues, deployment models are different. So you need to program firmware specific to these technologies. And frankly, at the end of the day, how many of us really care that much whether we're using LoRaWAN, cellular, Wi-Fi, or satellite? Or do we just want to get this thing connected? And that's where wireless harmonization comes into play. Because in this magical harmonized world, choosing a radio access technology can be more of a deployment time decision instead of a development one. So you can develop a solution, and when it comes time to deploy, then make that choice of cellular, of Wi-Fi, and or LoRa based on the specific needs of the actual destination you are deploying to. And this idea of wireless harmonization really goes beyond just harmonization of RAT. It also includes harmonization of location gathering technologies and the harmonization of data flow we get from the Blues cloud service Notehub. And we're going to touch on all of these today. But let's look a little more closely at the harmonization of RAT and what that has to do with the new line of note cards. Of course, I already touched on this, but here at Blues, as of today, we feel like you should be able to prototype with any wireless technology and deploy with any other without changing a single line of code. And when you choose to change, when you choose a RAT or when you choose to change a RAT, you should have confidence that they are fully swappable, which our note cards are both physically and in the APIs themselves. Likewise, you want to be able to future-proof your deployments. Someday in the not too distant future, 4G will sunset. That's a fact. When it does, you'll want swappable connectivity with 5G or a satellite note card, for instance. Not that I'm announcing those today in any way, shape, or form, but I think you know what I mean, like looking far into the future. Also, it's not necessarily about picking one RAT, but having the option to switch between them programmatically. This idea of cellular to Wi-Fi fallback is something we're going to look at closely today. So let's dive into these note card options that we have today. We can start with the existing, with the green PCB cellular only note cards. To be clear, these are still sold, still 100% supported. Truly great option if you only need Cat-1, LTE-M, or NB-IoT based cellular. There is a new lower cost Wi-Fi only note card based on the ESP32S3 chip. And there is also a brand new LoRa only note card, and we're going to talk about this one quite a bit, and a new cellular, dual cellular and Wi-Fi set of note cards that allow for using either cell or Wi-Fi, or even cellular to Wi-Fi service fallback that we're going to dive into here in a bit. So let's zoom in on each of these a little more closely. So since about late 2020, our core product at Blues has been the cellular note card. It's a low power device to cloud data pump, right? It runs on Cat-1, LTE NB-IoT protocols, ships with 10 years of global service, 500 megs of data, all for a flat cost. There are no SIM fees. There's no monthly subscriptions involved. And to be doubly clear, again, our green note cards are not going anywhere. We still sell them, still support them. Then we get to the new Cell+WiFi note cards. These are backwards compatible with our existing note cards, physically provided that your product has room for the slightly taller form factor of 42 millimeters. So I believe that's about 7 millimeters taller. Again, supported globally with the same data, same cellular service support, but also with onboard Wi-Fi and the ability to switch between them as needed. Like the green cellular note cards, our Cell+WiFi note cards do come in region-specific varieties, but we also have a new globally supported Cat-1 option that's super exciting. Then we get to Notecard LoRa. Now, when we announced this generated a ton of interest from many of you already. I'm sure you have questions. The Notecard LoRa does ship with support for either the US or EMEA LoRa frequencies. It does come pre-provisioned to immediately start working over the Things Network LoRaWAN gateways. So to be clear, you power it on and the data flow to Notehub just works. You're not interfacing with TTN. You're not paying them anything. We pay the Things Network just like we pay the cellular carriers. We will also be selling pre-configured TTN gateways soon if you need one. And I know many of you are also interested in getting a Notecard LoRa to work on a non-TTN gateway. That's something we are looking into, but we have nothing to announce today. All right. The Notecard LoRa is actually available starting today at $10. You'll also see this $5 chips edition. You'll see this show up for the LoRa and the Wi-Fi note cards. To be clear, these are volume purchase orders of 500 or more. They're produced on a reel and they're chips only, so not in the note card form factor. If you have questions about this, feel free to ask. I can follow up with you later to provide more details. It's a little beyond the scope of what we're going to talk about today. Now, for those of you who are excited about Notecard LoRa, first, you should absolutely be. I do also want to set expectations. If you know how LoRa and LoRaWAN gateways work, you'll also know that there are limitations in latency and bandwidth, especially when gateways are serving a lot or even too many devices, frankly. So don't necessarily expect Notecard LoRa to send and receive data exactly the same as the cellular or Wi-Fi note cards, because it's working within the constraints of the LoRa protocol. In the US, for instance, we are spoiled, right? We don't have duty cycle restrictions as we have a broader range of frequencies, LoRa frequencies available. So when you're writing an app, especially outside the US, you just need to be aware that you're working within the confines of the LoRa protocols. Specifically, when designing an app with Notecard LoRa, while the API is compatible, there are considerations to make. For instance, all note files must be templated to save size, save some physical size in Flash. And you also can't ascertain location data because obviously there's no GPS module, there's no Wi-Fi module to utilize Wi-Fi triangulation. With that, I want to hand the stage over to TJ and then to Zach. TJ is going to show us a little more about the cellular to Wi-Fi fallback feature, and Zach is going to dive into the Notecard LoRa a little bit more for us. So let me stop my sharing and you guys can take over.
Sure, and I can start. And I'll start by just holding up one of these guys. So I've got a Cell+WiFi note card and a Notecarrier F, just so you can get a sense of what this looks like. I think it looks pretty sleek. The name is pretty self-explanatory as well. Cell+WiFi communicates over cellular plus or Wi-Fi. And I want to show, so I'm going to bring up my screen here real quick to show you how this works. Now, the cool thing about this note card, like a lot of our, like really anything we do here at Blues, is that the setup is really, really simple. There are actually only 2 commands that you need to run to basically get a Cell+Wi-Fi Notecard up and running. And both of these might look familiar to them. The first one definitely should look familiar if you've done anything with a Notecard before. Our hub.set request. If you're completely brand new to Blues, this is basically just the default configuration you run on any Notecard. It's how you tell the Notecard basically which Notehub, which cloud backend project to associate the device with. It's basically the link between the physical device and the cloud. So that's one command you need to run. The second one is one that's also not new. This is something that was available for the V1 of our Wi-Fi Notecard, and that's the card.wifi request. It's another API that's fairly self-explanatory, but it's basically just the way you tell the Notecard which network it should use for the Wi-Fi connection. So in this case, I'm connecting this to my phone, connecting my phone because I'm going to take the phone's hotspot offline here in a second, but connecting to my phone's network, and I set a fun password for today's webinar. And what's cool is that's actually it. So I get the Notecard out of the box. I set up a Notehub project. I tell the Notecard which project. I tell it which Wi-Fi network to use. And I've now done all the configuration that I need to do. The Cell+Wi-Fi Notecard communicates over Wi-Fi by default and automatically fails over to cellular in case the Wi-Fi network is unavailable or it's not working for whatever reason. So to show that, I'll start by just taking an extremely simple note. We'll just note.add hello Wi-Fi, because this is going to be transmitted over Wi-Fi by default, because I still have my phone's network is still up and running. I'm going to go ahead and sync that. This sync should happen relatively quickly. I see it's already there by the time I get to this tab, because it's being sent over Wi-Fi. The other cool thing that's new, at least new to the latest 5.3.1 firmware version of the Notecard, is that the session note file, so the session QO note that is available that tracks sessions that are occurring on the Notecard, has a new field down in the JSON called RAT. So RAT for radio access technology. It basically just shows which communication method was used for this session. So in this case, by default, using Wi-Fi. So this session, all the data is sent over Wi-Fi, and my data came through over here pretty quickly because Wi-Fi connection very fast. Now, the cool thing about this Notecard happens when the Wi-Fi network goes away. So I'm going to go ahead and kill this network real quick, take it down. And I don't actually have to change anything on the Notecard. That's the real power of this. So what's going to happen is that when I go to work with some more data, and specifically, so I'm going to add this note of hello cellular, and specifically when I sync it, the Notecard is going to, again, attempt to send this data over Wi-Fi. But you can even see over here, Wi-Fi can't join, access point not found, because I took my phone back down. So instead, it's going to automatically sort of fire up its cellular modem. It's going to detect there's a problem with Wi-Fi and fall back and send it. You can see the modem is now being turned on so it can send this data over cellular. That's going to take a few more seconds because I haven't used the cellular modem yet. So by the time it fires it on and sends it, it'll take a few seconds. And what I wanted to show you is that there is a new API in the Notecard firmware, again in 5.3.1, called card.transport. It's set to dual Wi-Fi cell by default. So that's what I've been using as part of this demo. That's using Wi-Fi by default, cellular as a failover. But you can set this to explicitly just use Wi-Fi or cellular, which you might want to do for certain scenarios. It is nice for testing, like as I've been sort of experimenting with a Notecard and testing things out. It's been sort of a handy API to use. So I'd expect this data to come through by now. It is here. So I have the data over cellular. I have the session QO. So I formed a new session when I changed my RAT or my radio access tech. And oh, there it is. I just can't scroll correctly, but there it is, RAT of LTE, because I'm now sending this data over cellular. Now, this demo is kind of mundane, but that's actually kind of the point, because this is intended to be super seamless. That's what we're trying to do here at Blues, is make it so you don't have to care about basically the communication, the connectivity, the way this data is actually transferring. You don't have to care on the firmware side of things. So if I was writing firmware that sent these requests versus sending them in the browser, you see that I don't have to, I have to configure my Wi-Fi network, but I don't have to tell it when I'm sending and working with data what to send this data over. I'm basically letting the Notecard take care of that for me. And similarly, I don't have to care on this side of things. So I work more on the data side of things, and I don't care how the data gets to me, right? I just want to build a dashboard or get this stuff in a database or whatever. So I also don't need to care on this side of things, whether it's being sent over cell or Wi-Fi either, which I think is pretty cool. And that's really what we're trying to do, is trying to make these sort of processes really seamless, because we know a lot of you are looking for Wi-Fi connectivity with some sort of failover, which is what this Notecard is intended to do. And I should say too, and Zach, I'll use this as a transition to you, because really this is the same sort of thing we're looking for, not only for cell and Wi-Fi, but also LoRa as well, because it's the same sort of thing. If you want to deploy something with LoRa, you want to make it so your backend doesn't need to care about that, but just designed with the right Notecard for the right job. And Zach, I will go ahead and toss things over to you, because I'm excited to see the LoRa Notecard in action also.
Before Zach starts, I need to issue a correction. I was misled. We are not selling Notecard LoRa today in the Blue Store. It is still coming soon. Sorry, made a couple apparently.
Cancel my purchase order now. This is ridiculous.
All right, so well, let's talk about what the Notecard LoRa is. Let me see if I can share my screen and get a slide deck up here. Oh no, this is, so I run Linux for everybody here, and my whole life is miserable except for when I'm programming. And so right now we're going to go through a little bit of this misery together here. So I think it's this one. If I share this, what do you see? Yeah,
Notecard LoRa on a slide. Yeah,
you got a slide. All right, great. So we're talking about the Notecard LoRa. Let me see if I can advance the slides. Yeah, so Rob said this, but I just want to drive home that the LoRa is completely abstracted by the Notecard and Notehub together. So this is going to have to sink in while we go through this, because I can say this 1,000 times, and until you see it, it's really hard to believe. Like, I was working on it yesterday and still didn't exactly believe it until you make it happen, and then your mind is blown. So all right, so there's phase one. So how does that happen? Well, let's look at the Notecard abstraction first. So the cool thing about this, and it's like what TJ said, it's boring because nothing changes, except for that everything changes because the RAT changes. So the code won't change, and neither do the responses from the Notecard. So if I, with any luck here, if I can get, you guys see VS Code right now?
Yes. Yep. Looks good.
Wow. This is unbelievable. So, all right. So here we go. I have 2 logs up, and let me see. I'm going to try to go for the trifecta here and ruin everything. Give me just a second. I'm going to try to share. I'm going to switch my video. I'm not going to switch my video. That's not an option right now. In a minute, I'll show you guys my bench, and I have I have 2 of our dev kits that we sell, the Notecarier F, one with the LoRa note card in it, and one with one of the fancy new Cellular plus Wi-Fi note cards, and they're sitting side by side. So what you're seeing here on my screen are the logs coming out of these 2 things that are running side by side. The Swan that's driving them, also part of our kit, has the exact same firmware, like identical exact same, and I will show that. Not hand wave, not make you promises right now. I'm going to swap the MCUs in the socket here in just a second, as soon as I can enable my camera from my face to my bench. So we'll do that in just a moment. But you can see right now, the logs look identical between the 2. And if we scroll all the way back to where it began at the very top, you can see that, here we go, we have the same exact requests that are going through. You don't need to try to grok this right now, but you can see the shape of the logs looks roughly the same, and then eventually they all just come down into the exact same looking logs. It's a little bit boring, so you don't really need to pick through them, but I hope you get the idea that I promise you right now, the same code is going into both, and the note card is responding in like exactly the same to both. So what this means is your firmware does not change at all. Firmware is identical. All right, so with that in mind, so that's how the note card performs the abstraction over LoRa, as in you don't even know what's happening. You're just talking to a note card with notes. All right, and now the next is the Notehub abstraction. And just like Rob's already said this, but again, it's worth reiterating because you only need a Notehub account. You do not need mentioning even that it's the things network is mislead. I mean, it's not misleading because it's exactly what it is, and you need to have those in your area, or you need to have a gateway that you can talk to that's a things network gateway. But that's the only reason that it's important, because otherwise you would never know. Like, you're going to go set up your account, or you already have an account on Notehub. You create a new project. It's not a special LoRa project. It's just a project. You get the project UID and you put that in your code. That's it. Like, and as far as the billing goes that you would normally have to do with the things network or whomever, that also is abstracted. That comes as consumption credits on the back end of our stuff. And you don't need an account with them. You won't pay them. None of that happens. So it works out really slick. So Notehub is performing one half of an abstraction. Notecard is performing the other half of the abstraction. And again, the radio access technology is just a black box in the middle that you don't need to know or care about. Yeah, and so that's all my slides. It's just keeping it simple. Let's go. Now that we've talked about that, let me get out of this slide deck and come over here. So let me show you Notehub first, and then I'm going to show you I'll show you the things network piece just to pull back the curtain, just so you can see that it's actually running through and this isn't just an imaginary talk. But what I've got here are the two cards I just told you about. I have a Notecard WB-NAW and a Notecard LoRa. And so if I click on one of these and I look at the events that are coming through, what I'm going to see is I have temperature and voltage, and a whole bunch of other status stuff, or sessions, I guess. And then if I go, and that was the WBNA, and if I go to the Notecard LoRa and I look at its events, what I'm going to see is temperature and voltage, temperature and voltage, temperature and voltage. Now, you're not seeing all the session QO stuff because it's coming in directly from the things network. Again, it's fully abstracted, and the part that we actually cared about, the part that my firmware is doing, is it's capturing temperature and voltage. So the session stuff is interesting metadata, but it's not the meat and potatoes of my application. So if we look at the two of these, we're getting the exact same body here that will be forwarded onto the app, whatever our endpoint web application is, whether that's our AWS account, our Azure account, our fill in the blank account, or your own local servers, however this works for you. Your body, the payload, makes it from the beginning to the end, and you don't know or care how it happened in the middle. You gave us JSON, we gave you back JSON. The rest that's on us. So, all right, and then let's look at what's happening. So I'm going to peel back the curtain. We'll look at the things network. You can see here link messages. This is what you saw when you saw voltage and whatever the other thing, temperature maybe, that I just showed you. And these are all the messages that just get forwarded on to Notehub. So again, this happens without you knowing, without you having an account, without anything, but it is happening. I just wanted to show you to assure you. All right, so that's the website. I'm going to try to do the flip-flop and see if I can break my Linux laptop, and I'll probably have to drop out of the call whenever this goes down in flames. But let's go ahead and give it a try anyway. So if I come over to my video, let me see if I can get us on the desktop. So yeah, okay, here they are. Here are the twins. We have my fingers are too big for pointing. I'll use this Allen wrench. So this is your note card that's with LoRa, the LoRa note card. And then this is your WBNA-W that TJ just showed off. And so they're running side by side. So what I'm going to do here is I have a switch right here to turn off the LoRa one. And then I have this one on a battery here. So it was overwhelming my USB host. So with all the power drawn, so I had to throw a battery in the mix. But anyway, all right, so they're turned off. And now I'm just going to take this one out of this socket and this host out of this socket, and I'll flip-flop them. Let's see if I can get them in the socket correctly. All right. It's not really a shell game here. There you go. So this will prove that these have the exact same firmware on them, and they're both capable of running it. All right, so let me go ahead and plug, here, can I show you? No, probably not. All right, I'm just going to go ahead and plug this back in, just get it going. And then what you're going to see is some new startup messages at the bottom of the logs, and you'll see that they both have turned on successfully, unless the demo gods wish to thwart me as usual. But here, let's find out. So I'm going to share my screen one more time. And, oh, here we go again on this thing. And it's that one.
You're good.
You guys, what do you see on this? Oh, you see, okay, great. So let me get you back to...
See the Things Network right now.
Are you guys looking at VS Code? Somebody say yes.
Yes.
All right, great. So right here, you actually see it right now. You can see that at the end of all my logs from before, I come in here, it reboots, and they're running just like before. So I was able to completely switch. So your host can always just switch between the two, and you're off to the races. Anyways, it's incredible technology. I hope you guys are excited about it as me. And like I said, the first slide, like the Notehub and the Notecard abstract everything that has to do with LoRa. You're just doing the same stuff you've always done. All right, and now I'm going to turn it back to Rob.
Perfect. Thanks, Zach. And we only see VS Code in your screen, by the way. So
it's Linux, man. Don't worry about it.
Yes.
That's more tech anyway.
All right. So thank you, TJ. Thank you, Zach. I do want to move on to the second of the 3 wireless harmonization topics, this time to focus more on location. So all location-aware devices are not created equal, right? For example, if you're using GPS, you can pretty easily ascertain a location outdoors, right? You have a clear view of the sky, you have enough time to get a satellite fix and all that good stuff. What about when your asset moves here, here, or here? When it's indoors, GPS is no longer going to function. So what can we at Blues do about that? Well, let's talk about the limitations of GPS a little bit. It is the most accurate of location technologies, but it does suffer from the fact that it's very power hungry, and it can take a very long time to ascertain its location. It also doesn't work indoors, like I just alluded to. So this is really where the onboard Wi-Fi chip on the new Notecard Wi-Fi and on the Notecard Cell+WiFi come into play. So this Notecard, this one in particular, is a new improved lower cost version of the existing Notecard Wi-Fi. It can also utilize a powerful piece of location tech that we like to call Wi-Fi triangulation for indoor location tracking. And just to be doubly, triply clear at this point, what we're about to show you works the same on the Wi-Fi only Notecard and the Cell+WiFi Notecards. And this is where I want to invite our senior developer advocate, Kimball Johnson, to demo this functionality. If you didn't join us at the beginning, Kimball literally just got off of a plane. He's based in the UK, but he was at an event here in the US. So he just literally by minutes made it in time for this webinar. And I'm going to start here by showing off a video Kimball just recorded. Give me a moment to share a video here. It's a lot of clicking. And pick the video, and
I'll know too, while Rob's bringing this up, if anybody has any questions, we're going to take those at the end. So if you want to drop them in chat or Q&A,
and
that'd be amazing.
I'm going to play the video now.
I'm down on the deep level underground line in Bermondsey to demonstrate the features of Wi-Fi triangulation that is in the new Cellular plus Wi-Fi Notecard. This happens every time you do a sync if it's turned on, which I'll show later. But first of all, let's initiate a sync while we're down here on the underground. Now it's connecting in, and when it's connected in, then we'll be able to show the actual location that's coming up. So the sync is completed. It's done it. That's fine. Now if I refresh on the poops here, we should see that we'll get a location showing up of Rotherhithe, England, and then we bring that up in Google Maps, and you can see that this is right by Bermondsey Underground.
Awesome. So, Kimball, feel free to take over.
Okay, well, I don't have any more slides for that, but I will bring back up the Notehub again in a moment. So one of the things I said in that is that I had enabled the location tracking. It's actually enabled by default automatically on both the Wi-Fi note card and the Cellular plus Wi-Fi note card. I was having a lot of trouble recording, and you're not supposed to record video while you're on an underground, so I was being a little bit surreptitious so I didn't want to re-record. But so that happens all the time. And I say, obviously, I was 15 stories down deep on the underground, so no chance of any kind of location tracking. Now, let me share my screen and I will show you the where we are as well. So one thing to show here, that if you are setting up like the triangulation, you can see I've got a few things setting. We got
Kimbo, real quick, can you bump up the font size like 7 inches real quick, please?
Good point. There we go.
Perfect. Thank you.
Yeah. So you can see here from the settings that we've got triangulation mode on Wi-Fi, and you can see the last time that it moved. This on true means that it will actually send the location every time, even if it hasn't moved, which was useful for the demonstration when I was sitting in one place on the underground. All of the settings for triangulation are in the documentation here. So there's a lot of settings here. So on the normal API reference, you can see all the various documentations here. So it's pretty simple, just the same as any other request on the Wi-Fi. Now I want to show you here as this is again before where I got the location, and you can see here again it's in that location and on the underground. This is a bit small again as well, so I'll just make it as one thing I wanted to bring attention to is this little icon on Notehub. That means that it got a triangulated location. Alternatively, you can see here, this is where I was at home, and it just gets the location of the tower before triangulation is turned on. And so you'll see like what the best location is. So you might just have the tower location, you might get a GPS location, you might have a Wi-Fi triangulated location, and Notehub is always going to show you the best that you get in this and show you a little icon for there. Also, just to prove that it wasn't a complete fluke, here's another one that I did when I was at Canary Wharf, and again, I mean, it looks like I'm in the park, but I assure you, I was right underground again on this one as well. Showing it's the Wi-Fi triangulation was working underground. And I think this is a super great thing. Now, not everyone's going to be wanting to do Wi-Fi underground on the London Underground, but the concept applies to anywhere where you've got good quality Wi-Fi. And a bunch of Wi-Fi access points. So inside a building, say you're in a shopping center, say you're at, you've got a whole bunch of access points, as we showed there in a car service center. The ability to be able to get that quick, low power triangulation on Wi-Fi, rather than having to rely on the slow, high power GPS, is super useful. Now, obviously, there's cases where GPS is better. All the automatic tracking of location that's built into Notecards that and been using for years is there too. But I think this new Wi-Fi triangulation is a huge boon to what we have on top of that. So yeah, I think that's what there is. So I think that's all I've got to talk about there. Hopefully you found the demo useful.
Awesome, thank you, Kimball.
And I'll say too that even if you're not in an area like London, when I first got mine and turned it on, it was accurate. So it even knew like what corner of my house I was in, which shocked me because I'm in a pretty suburban area. We only see like maybe 6 or 7 Wi-Fi networks from neighbors and such, and it still knew like exactly where I was, which kind of blew my mind a little bit.
Yeah, I mean, absolutely. I mean, I live right on the outskirts of London, and which is why I didn't click on the bit to show showing where I did get the triangulation for home, because I don't really want to show you where I live exactly. But it was very accurate.
Cool, thanks, guys. So I want to next transition into the Blues partner ecosystem. So like-minded partners are really critical to our success, and therefore, frankly, critical to the value that we can provide for you all. As I mentioned at the beginning, we've been working with RAKwireless on a couple new RAK branded products that feature the Notecard, one of them in their WISblock ecosystem. Really exciting stuff. To show these products off, I wanted to virtually welcome Carl Eric Rowan. Carl is on the line, but he's based in the Philippines. I'm surprised he's here because I think it's like midnight or 1 a.m. I'm not going to put you on the spot, Carl, but we do have a video segment to show that Carl recorded. It's a short one, about 7 minutes. And again, allow me to awkwardly switch over to a video. And I'll play it now.
We are very excited to collaborate together with Blues in the launch of their new sets of note cards, and together with RAKwireless WISblock modular IoT hardware platform, let's see how we can integrate these two technologies together and create meaningful and exciting IoT applications. Let's now start with the hardware that we're going to use here. So first would be the WISblock base. So this baseboard is the RAK19007. So this will hold all the components and the modules that we need. In this side, you have the CPU slot. So this will have the WISblock core. It also has sensor slots here. Sensor slot A, B, also at the back for the sensors. So it can accommodate up to 4 sensors. And then the I/O slot will hold the Blues note card. So we will put the note card here, and then it will establish the connectivity on the cloud. So this is the WISblock baseboard. Next component, of course, is the WISblock core. So this WISblock core is based on RAK4630 LoRa 1 module. This will be programmed by Arduino, and this will get the data from the sensor, and then it sends command to the note card so that it can bring the data to the cloud. The sensor that we'll be using here is this. This is an environment sensor. It has temperature, humidity, and pressure data. Next module that we need is this one. This is a new module that we will launch under WISblock platform. So this one would be the board that will hold the note card. So as you see, this has a connector here that matches the note card. It also has a SIM card slot here. I have a SIM card already there. And then it has a USB-C connector. So this one will be placed on the WISblock baseboard I/O slot. So it will be placed here. As you see, the WISblock, the Blues note card has a big form factor. So it will cover the slot A and slot B. So to compensate that, we allotted the slot A and slot B here. So even if it's covered, you still have access to it. So this is the next component that we have. Of course, the star of the show, we will not forget the new Blues note card. So as you see, there are many IPEX connector here. We have the virtual antenna here. So this has multiple connectivity options. So for this one, we will use this for the cellular feature that it has. We will not forget the antenna, of course. So this one is the antenna that we will use for a note card. It's a Molex antenna. It has this range for the cellular connectivity, and then this one is for the GPS. Basically, these are all the things that we need, so we can start. Of course, we shall not forget this one. So this is a option on our board here, so that you can power it using external power source. So you can put it here, and then you can put this the wires to a 5-volt supply. So from there you can have external supply to it. I can do it, and you can do that, and then you can put the USB connector here, then you can communicate on the Blues note card here. So you can connect it to the PC, and it will be detected as a serial port, and then you can start configuring it. So we'll do that later. So this would be the setup that we'll be using during configuration on the note card on the Blues platform. Of course, you also have the LoRa 1 antenna for the LoRa 1 module. You also have a USB cable. You should not forget this one. We have to connect this to the PC. And just to share, aside from this kind of baseboard, it also supports a bigger baseboard. So this is a big baseboard WISblock module, and it has different kinds of modules attached to it. So you can also attach this So when we attach the note card here, we can also attach it here. So right now it has different, you can now communicate or send the data of these sensors to the cloud. So the PIR, you have accelerometer, light sensor, and also some sensors at the back. So this is also supported by this kind of WISblock baseboard. But for now, we will settle on the generic, or the general baseboard that we're going to use. Everything is attached now, as you see. The core is connected to the base, the note card is connected to the IO slot, and the sensor here is connected at the back. So we can now connect it to the USB, and we can start configuring and then uploading the Arduino code, and then we'll see the data on the Blues platform. Now that we have the note card successfully connected to the Notehub.io, we can now upload the sample sketch in our Arduino IDE and see how we can transfer the sensor data to the cloud. This will be our setup now. We're connecting the USB port on the WISblock module, and let's upload this code. So the code is now uploaded, and we can see the code here. This will be accessible in our quick start guide for WISblock and the note card. And let's see the serial terminal. I will reset the module, the WISblock module, and we will see the console output. So as you see, the BM680 is detected, and then it will try to check the note card. Then after that, it will get the readings of the sensor. After that, it will add it on the note, and then it will sync. Then it will continuously check the status of the syncing, and after that, it should be present now on the Notehub.io. So we can check that now. So this is the Notehub, and as you see, we have the data transmitted. The data is transmitted every 2 minutes, so you can see it here, like this one, 56, 58, 40. So these are the data that is transmitted to Notehub.io. So the next step is to create integration. There are tutorials here in Blues, and yeah, this is, after this you can now create your exciting and interesting IoT applications. So I will now give back to Blues, and we're really honored to be included in this webinar.
Awesome. Let me stop the video. Whoops, wrong video. And
I was fine with you stopping both videos. Really.
I know. Here we are, we're back. So I'm super excited about these new products coming from RAK. Of course, once these are available for sale, we'll be sure to let you all know in our developer newsletter coming up at the end of the month. Lastly, today, I wanted to really briefly touch on the last of our 3 harmonization topics, and that is the harmonization of Dataflow. When you choose Blues, you're not just choosing the note card, right? With Blues, it is really possible to develop a single solution that can be deployed with any host, and then use cellular, Wi-Fi, and or LoRa, and you're really not jumping through a lot of hoops to get you to this point. Not only that, but that single solution with multiple RATs, multiple deployments, still has the benefit of communicating with a single cloud service and a single pipeline through to your ultimate cloud application. Now, while I don't have anything net new to announce today regarding this data flow, this is just an important reminder that using the note cards with Notehub enables this really seamless workflow. And so hopefully you've gotten an idea of how wireless harmonization is a massive part of what Blues is about today, and especially looking forward. And this is really critical to our success, and frankly to your success, because at Blues, we're helping to connect these unconnected devices, to find devices anywhere, and to use the cloud to distill figures down into facts for you. And with that, here's one more reminder of the products we just released. All except for the Notecard LoRa are available today at shop.blues.io. I hope again you've seen how this set of product releases for us really helps to tell a more compelling story of wireless harmonization in the IoT. And of course, your journey starts on our developer site at blues.dev. You'll find the guides, the data sheets, the API references that you need to be successful with the Notecard and Notehub. With that, I think we have time to answer some questions. So let me...
Yeah, I should probably clarify a little bit about my demo on the underground, because I've seen a question come through of it. So the underground has a huge Wi-Fi connectivity. It's across the vast majority of the underground. However, it's not super simple to connect to it with without a mobile, just rather than a mobile phone. It's all tied into mobile phone contracts getting it. So I was on one of the few places on the underground that has both cellular and Wi-Fi connectivity. But I deliberately set up the triangulation to be using Wi-Fi only. So it was triangulating using the Wi-Fi and then sending data over the cellular, which I think is actually as well a kind of a great thing about the ability of having both cellular and Wi-Fi on the one note card, is that you can rely on the Wi-Fi triangulation for your location, but the cellular data for actual connectivity. So I hope that clears that up for the people that were a little confused.
Yeah, because even if you're not using Wi-Fi for connectivity at all, the Wi-Fi module is what enables you to discover those networks to perform the actual triangulation. So even if data is not flowing over Wi-Fi at all, the module just enables that, basically that positioning through triangulation.
Yeah.
So I had a question out there from Clark, and basically he saw me in Cassville, Missouri, so repping the Ozarks hard here. That's right. And asking where I got a TTN network gateway from. I brought my own. So this is something you'll also find in our store. And this is going to be a pre-provisioned, a pre-provisioned gateway, so that you can just plug this in, hook it to your Wi-Fi or some form of internet. And then you will also have LoRa, so that way, if you had a test bed, or if you had some kind of home automation or something, it would all still work just fine. So that was to answer that question. And then I think I saw another one about, instead of using the Swan, which is an L4R5, a U5 STM chip, it's all just the same. That's part of the cool stuff about the note card. You'll either use the I2C or UART. And that's the two ways you talk to the note card, and you send it JSON. And we have libraries and SDKs to help with that. So it really, it's as simple as can be. They were typing them live. If you saw any of the things that they typed in to do, they're called, we call them requests. You would have seen a few of them live in this video, and that's all you have to have your firmware do, is generate that little JSON object and send it across either our serial over I2C protocol, or just UART directly. And the note card reads it as JSON, parses it, and does what you want. It doesn't transmit it over the wire as JSON, so it's not a huge waste of space. It compresses it all down, but that's how it works.
Cool. A question came in earlier. Will you be discussing the ongoing costs of a cellular modem? I'm assuming he's referring to Notecard data costs and Notehub. It's a great question, and we're super upfront with ongoing costs. So when you purchase the Notecard, it's a one-time fee, right? Obviously, depending on which Notecard you're buying, it's either anywhere from $10 up to, I think, the most expensive cellular Notecard is $70 or $80 US. And that does, to be clear, the cellular ones do come with 10 years of service, 500 megabytes of data built in. And that's it. Once you go beyond 500 megabytes of data, you have the option to effectively top those up with another 500 megabytes of data. That cost is $10, again, a one-time fee. $10 for, somebody can fact check me on this, $10 for US-based note cards, US region, North America, sorry, and $15 for international.
Yeah, that's correct.
And on the Notehub side, we have a consumption-based model, not a subscription-based model. And what we charge you for is event egress out of Notehub. You can send as many events or notes as you want to Notehub, and we're not going to charge you a dime. As soon as you start routing those out, each routed event is one consumption credit, and you by default, with a Notehub account, get 5,000 of those for free every month. Or I should say, we top you up to 5,000 every month. If you go beyond that 5,000, that's when you're paying us. And even those per event charges are as low as it's a fraction of a penny per each, and you can bulk purchase and get discounts and on. The reason I'm just explaining this whole thing is because I want to be very clear that we're not trying to monetize on individual developers, right? As you're prototyping, as you're just getting started. If you're a light user of Notehub, you can use us for free forever. That's fine. It's only when you're successful with us that we can both kind of monetize together and both be successful. So that's kind of the point of our pricing model.
I'm going to touch on a question from John. He says it's a silly question, but I don't really think it is. Basically, building a tracker to be used on a kid, like in cars and buses, and the difference between Wi-Fi and GPS location. And I'd say, because he says he's not having success with GPS at the moment, GPS is definitely the gold standard in terms of accuracy. You're going to get the most accurate location first for GPS, GNSS. But if you're having trouble with it, I would give Wi-Fi triangulation a shot. I think it's going to work probably well enough to meet your needs. The only time it's really not sufficient is when you get in an area where there's pretty much no Wi-Fi connectivity at all. So if you're tracking a kid and the kid's mostly going through a residential area, there's going to be Wi-Fi networks. So I might give that a shot and just see how it goes, especially if you're struggling with GPS.
I see Francois just had a question in chat about where can we get detailed coverage of the Things network. There is a, if you do just a web search for Things network map or something like that, you'll get a listing of all the public LoRaWAN gateways. In coverage in Europe is fantastic. Coverage outside of Europe is sketchy unless you're in an urban area. So as Zach pointed out, we are going to be selling some indoor gateways, which are fantastic for, obviously, for a house like those, what we're demoing inside of, but more likely like in a warehouse setting where you're managing 10 or more devices, and you want them all to have LoRa-based connectivity, connecting to one internal gateway.
So a question from Randy about confused on the RAK solution. Will the LoRa card work with the existing Notecarriers, or for the LoRa card, will you require the RAK solution? So the RAK is a separate offering altogether. So if RAK, their stuff works, their Notecarrier is going to work with their ecosystem of sensors and their WISblock ecosystem. But it's sort of an optional thing. You don't need to use any of that. LoRa is a completely separate thing that you can use with any of our Notecarriers or with third-party Notecarriers as well.
And there was a question earlier if hidden SSIDs are supported for the Wi-Fi Notecards. And yeah, the only difference is when you are configuring the Wi-Fi Notecard, you have to use the card.wifi API to register the SSID and the password. There is a different way of provisioning a Notecard Wi-Fi with you can actually provision it with your smartphone. That would not work because you would need to be able to, actually your SSID would have to appear in a list, I believe. Although now that I said that out loud, I'm not entirely sure that's true. Anyway, the answer is yes, there's definitely a way to do it. It may just be one of two ways. Any final questions coming in?
I've seen Bluetooth a few times. At the moment, there's no Bluetooth integration of any sort planned with the Notecard.
I see Clark had another question about I could send several tags within one message out of Notehub every hour, consuming 720 events per month. There'd never be a charge. Yes. To answer, yeah. So I mean, again, if you are a minimal user of the Notecard and Notehub, I mean, you'd be surprised how little data is used with each one of our requests. And you can track not only event usage, but event egress usage, but data usage as well within Notehub. And there's APIs to track your usage as well. And
the original intention, it's worth mentioning that the original intention of 500 megabytes was that it could last for 10 years. I mean, that was the goal. at the beginning. And now people have come up with ideas of wanting to send partial images and things, and that kind of blows that out of the water. But if you're actually truly sending diagnostics and sensor data, 500 megabytes takes a long time to burn through.
Francois has a great question. Is there going to be a Wi-Fi and LoRa Notecard in the future? Who knows? Anything's possible, right? It'd probably be up to ST to develop the chip that we can use for that. But sure, we're always looking to improve and expand in the future. With that, it's almost top of the hour. I think it's a good time to shut things down here. But if you have any future questions, be sure to hit up our community forum at discuss.blues.io. We'll be happy to answer your questions there.